All right, so this is about equilibrium shifts, and there are a lot of ways to think about this. You can actually do it mathematically. We're going to just try to stick to this conceptually for this particular problem. So the best way I find to do this is to make three columns, and the columns are the initial action that was taken, what the response to that action will be, and what the result will be. And we'll see how this works in a minute. So I'll set up these columns. And so our initial action, the first one, oxygen is removed from the system. So what is the response of the system going to be? And the idea is when something's at equilibrium, if something's balanced, anything that is done to it, it is going to try to, if something's changed, it's trying to eliminate that change. It likes being balanced. It's like if something is pushed to the left, it's going to try and balance by pushing back to the right. So if oxygen is being removed from the system's response is going to be to try to replace that oxygen, to add it back. And so that's the response. And the question is, which way is this going to shift in order to add more oxygen? Well, if I want to add more oxygen, I'm going to shift towards the left to break down more of this O3 and make more oxygen. So my result is going to be a shift to the left in this particular case. Next, my next action is O3 is added to the system. So I'm putting a stress on the system by adding extra O3. The response is going to be to get rid of all that extra O3. I want to remove it. So the question is, which way is going to remove O3? Well, if I go left, I am breaking down my O3 and making more oxygen. So again, the result is going to be a shift to the left. Next, the temperature is increased. Now we need to figure out what this really means. If the temperature of the system is increased, that's basically the same as adding heat. So if we are adding heat, the system wants to remove that heat and is going to accomplish that by using that heat in a reaction. So it's going to use this heat and is going to shift it to the right to produce more O3. All right, this next one might throw you off. And the reason is volume isn't really a valid stress in this case. What is increasing the volume of the container going to do? And this is simplifying a little bit, but basically increasing the volume is going to lower the pressure overall. And so if we lower the pressure, the response is going to be to increase the pressure. And so then we look at our stuff and say, okay, which direction is going to increase our pressure? Is it going to be producing more O2 or producing more O3? And the key to this is counting the number of gas particles on each side. So on the left, we have a total of 3 gas particles, 3 O2s. And on the right, we have a total of 2. So if I want to increase the pressure, I want to go to where there are more gas particles. So I want to shift this then to the left, where there's more. If I take 2 gases, I can make 3, and that's going to try to replace it. Now this isn't exactly what's going on here. It can be a little more complicated than that. Actually, let's explain that in the next one. Helium gas is added to the system. So adding helium gas is going to indirectly, well, not really indirectly, it's going to increase the pressure of the system. However, it is not a reactant in this case. It's not increasing the pressure. It's not increasing the partial pressures of the O3 and the O2. That's really what matters, is are O2 and O3 increasing at all as a result. And so adding an inert gas, bottom line, like helium, you could say the response is going to be remove helium if you want. How is it going to remove helium? There is no helium. So basically this is going to have no effect, adding helium gas to the system. It's just there, it's going to get in the way, but it's not really going to do anything. So that might not be the best explanation for that. But anyway, for the most part, what you're looking at is here's the action, what's the response, what's the result going to be. And for pressure, the only time pressure is going to matter is if the container size is changed. Adding additional gases that aren't part of the reaction to increase the pressure will not have any effect. So lowering the volume will matter, or increasing the volume. So anyway, until next time, I'm Derek Genova. Have a delightful day.